All right, now here's part 2 of the solution guide for chapter 4 review. So let's see, we've got the integral here now. To find the area, we need to do the integral, and you don't need to worry about the y value. This fact that it goes up to 1 is irrelevant. You just need to worry about the x values. So we'll use the lower limit of -1 and the upper limit of +1. 1 minus, excuse me, I miswrote that. Let's go x to the 4th now. Okay, so the integral of 1 minus x to the 4th should be x minus x to the 5th over 5, and we will evaluate that from -1 to 1. Okay, so if I plug in a 1, I should get 1 minus 1 to the 5th is still 1 minus a 5th, and then minus, and then all in parentheses, make sure I should get a -1 minus -1 to the 5th is still -1 over 5. Okay, so I should end up with, let's change that to a plus, and if I added this one to that, that would be a plus, but now it's a minus. Okay, I think that's all right because there's 2 minuses there, so that makes a plus, and then minus that, and then changing that should make that a minus. So what we should end up with then is, okay, this then here and this then here should become minus 2/5, and then this and this is 2, so we have 2 minus 2/5. So we should get 1 3/5, or as a decimal should just be 1.6. I'll just leave it like that. That looks fine. All right, let's look at number 12. Number 12 is the cosine. Now don't worry about that. That's the y value. You need to worry about the lower limit, which is 0 there. So we should go from 0 to pi over 2 of cosine of x. Okay, the integral of cosine, if you don't remember, just look it up in the front of the book, should be the sine of x. And we'll go from 0 to pi over 2. So that means I just plug it in, sine of pi over 2 minus sine of 0. Okay, pi over 2, if you think of the unit circle, pi over 2 is all the way at the top, so that means sine is 1 minus 0. Sine is 0, so should just get 1. Okay, let's look at 13 here. Okay, 13 is t to the second plus 2. Okay, I can show you a couple ways to do this. First, notice that this is an even function. All the powers are even. You have a t to the second and then a t to the 0. So we'll take note of that because there's a quicker way to do that, but we're going to go here. Integrating this, we should get t to the 3rd over 3 plus 2t, and then we'll just plug in -1 and 1. So if I go t to the, let's see, instead of t, it'll be 1 to the 3rd, which is 1 over 3 plus 2 minus negative t to the 3rd should just be a -1 over 3, and then minus 2 in our case. Okay, so distributing that through, that should be a plus, and that'll be a plus. So now I should have 4 and 2/3. Okay, now the easier way to do this, if you notice that it's an even function, you can do it this way, because even functions are, you know, identical on, are reflections over the y-axis. You can just double it and then cut your interval in half and just go from 0 to 1 of t squared plus 2 dt, and you'll get the same thing. It's a lot easier, except for you just don't have to count for that, because you see here this one and this one the same thing, so it's like doubling it. Okay, kind of the same thing on number 14. Here's what's gonna, well, excuse me, not number 14. What we're gonna do here is, again, we'll start the integration. So we'll have 3x to the 3rd over 3 plus x squared over 2 minus 2x, and we'll go from 0 to 3. Okay, those 3's cancel, so make that a little easier. So we have 3 to the 3rd plus 9 divided by 2 minus 6, and then just minus a big 0. Okay, 3 to the 3rd is 27. I probably should have figured that out before. 27 plus 9 over 2 minus 6. 27 minus 6 is 21. So 21 plus 9 halves. Getting a common denominator, if I put a 2 on the bottom there, this becomes a 42. So then I should end up with 51 halves. for that one. All right, let's look at number 15. 15 is actually a little easier than it looks because you can distribute that through that t to the 1/2, or that t to the square root of t to make it t to the t. You can think of it as t to the 1/2, t to the 1/2 power there. Whoops. So now we have 2t to the 1/2 minus t to the 3/2, and then we can integrate that for dt, and we have to go from 0 to 2. So 2t to the 1/2 should be 2 t to the 3/2 over 3/2 minus t to the 5/2 over 5/2, and we'll go from 0 to 2. Okay, doing a little simplification here, we should end up with 4/3 t to the 3/2 minus 2/5 t to the 5/2, and we'll still go from 0 to 2. Okay, so we should end up with 4/3 t to the, or 2 to the 3/2 minus 2/5 2 to the 5/2. Okay, and then all minus 0 over there. So, okay, and so we should probably use a calculator here. So, and what I come up with is about 1.51. Okay, so you may want to check my math on that and email me back or something. All right, number 16. Number 16, we'll take a u substitution. So let's let u equal x to the 3rd plus 1. Therefore, du should equal 3x squared dx. Okay, so I've got the x squared. I just need a 3, so let's put a 1/3 out in the front. So then it's 1/3 the integral of u to the 3rd du. So 1/3 integral of u to the 3rd is u to the 4th over 4. And we'll go from 0 to 1. So I have u to the 4th over 12. Like that. So now I think I'm going to do a little trick here so I don't have to plug x back in. I'm going to figure out what 1 is and what 0 is. So I'm going to plug those in there, and then I'll just keep everything in u. So if I plug in 1 for x here, I get 1 to the 3rd, which is 1, plus 1 is 2. So my new upper limit for u, not x now, for u is 2. If I plug in a 0, 0 to the 3rd plus 1 is 1. So now I can just plug in the 2 and the 1, and I don't have to go back to this. I don't have to plug x to the 3rd plus 1 back in. So I should have, let's see, instead of u, it's 2 to the 4th over 12 minus 1 to the 4th over 12. Let's see, 2 to the 4th should be 2 is 4, 8, 16. 16 over 12 minus 1 over 12. So I should end up with 15 over 12, and 3 goes into both of those, so we should end up with 5 over 4. And let's look at the very last problem here. Alright, so let's let u equal x squared plus 1. Du then should be 2x. Okay, so I've got the 2 dx. So I've got the 2, or I've got the x, I just need the 2, so let's put a 1/2 out in front. So then we'll go the integral, 1/2 the integral of x, u to the 3rd du. Well, then that should equal 1/2 the integral of u to the 3rd should be u to the 4th over 4. So that should be 8 on the bottom. So we have, then we'll go from -1 to 1, and we have u to the 4th. So it's u to the 4th over 8. So, and I'll do that trick here. Instead of plugging this back in for u, I'm just going to take these numbers and plug them into there and get my new upper and lower limit that I can check. So if I plug in a 1 there, 1 to the 2nd is 1, so that's a 2, and a 1 to the 2nd plus 1 is, excuse me, a -1 to the 2nd plus 1 is also 2. So you should realize something here. I'm going to get the same thing. I'm going to get 2 to the 4th over 8 minus 2 to the 4th over 8. Well, that should just be 0. Okay? Now, another thing you could have noticed is that, hey, this is an odd function, which is actually kind of tough to see, that you realize that this is an odd function, but it is. So if you think about it here, you have everything's even powers on the inside of that formula, or in that parenthesis. So that means an even number times an odd number is still even. So that means everything's even so far. But then you're going to take it times one more one more variable, which means all your evens, you're adding 1 to every even exponent, which means now they're all odds. So if everything's odd, it's an odd function. The thing with an odd function is if your upper and lower limit, if they're the same number, one's positive, one's negative, your area should always come out to be 0.